How AI works with massive datasets. Applications, like Microsoft Windows or iPhone apps, need clear instructions from programmers to work. Programmers code input, what you give, and output, the result you see. This traditional programming approach doesn't work well with artificial intelligence, AI. AI faces too many possible combinations to tie every input to a specific output. For AI, you need a model that allows machines to learn on their own. AI systems also need feedback to improve. Imagine creating a program to detect spam messages. Spam messages often have ads or harmful links. A simple way to detect spam is using a word filter. For example, you can program, if the message contains gold or winner, treat it as spam. But this method struggles with more complex challenges. Machine learning, ML, changes the approach by letting machines learn from data. Instead of instructions, you give the machine data to analyze. Instead of programmed responses, machines find patterns in the data. A good starting point for ML is supervised learning. In supervised learning, data is split into two sets: training data and test data. Training data is smaller and is used to teach the machine. The test data is larger and is used to check how well the machine learned. Machine learning uses algorithms to learn from data. Algorithms are like mathematical tools that find patterns in the data. For example, an ML algorithm might learn that if an email contains "lucky winner," it's 50% likely to be spam. The algorithm keeps improving until it becomes accurate enough. Once trained, the model is tested on a larger set of test data. Test data usually has no labels, spam or not spam, to simulate real-world challenges. For example, you might train the machine using 10,000 labeled emails. Out of these, 9,000 emails could be regular, and 1,000 labeled as spam. After training, the machine applies what it learned to a test set of 1 million emails. This test data is not labeled because it's too much work to label all. The machine uses its algorithm to identify spam from this test set. If the results are accurate, the data model is ready for use. In this example, the ML algorithm has two choices: spam or not spam. This is called a binary classification challenge, as it involves two categories. Binary classification is one of the most common ML tasks. The key idea of ML is to use statistics to discover patterns. Once patterns are identified, the machine classifies new data based on what it has learned. Machines don't need to be told every step, they learn from examples. This saves time and allows machines to handle large-scale data. Machine learning is used in many areas like spam detection, image recognition, and more. Supervised learning is just one type of ML, but it's easy to understand and widely used. Remember, the power of machine learning lies in finding and using patterns in data efficiently.